Hello, everyone, and welcome back to Beyond the Business. In the previous episode, I talked about the fuel and about why modern energy systems became so deeply tied to burning things, and why that logic still shapes our economy today. But fuel was not the first attempt to escape human limit. Long before coal, oil, or gas, there was another idea, a much quieter one, an idea that did not involve fire at all. There was a water. And I would like to talk about the hydropower. So, hydropower often enters the conversation as something modern, something green, and something clean. But if you slow the story down and look carefully, you realize that hydropower is not a new solution at all. It is one of the oldest attempts to turn nature into stable, controllable energy. And that history matters because it explains both its strength and its limits. So today, let's step back again, not to debate climate targets or technologies, but to understand how hydropower entered the system in the first place and what kind of logic it brought with it. If we go far enough back, energy once again looks very, very different. For most of human history, water was not electricity. It was movement, rivers turned wheels, wheels powered mills, grain was ground, wood was cut, metal was shaped. Long before engines, water became the first source of energy that worked without rest. What made water special was not just force, it was continuity. As long as the river flowed, energy was there. Day and night, summer and winter, unlike human or animal labor, water did not get tired. And unlike firewood, it did not need to be constantly replenished. This was quite a revolution. Energy moved from the body into the landscape. Villages, towns, and early industries began to organize themselves around rivers. Geography slowly became destiny. And this is where an important pattern appears for the first time. Energy was no longer only about availability, and it became about location. Where the river flowed, industry followed. Where it didn't, growth stopped. So when the industrial era began in the 19th century, hydropower naturally expanded with it. Factories needed power that was steady, predictable, and strong. Water offered exactly that. Before electricity grids existed, rivers acted as natural infrastructure, concentrating economic activity along their banks. Then came the real turning point. Towards the end of the 19th century, turbines and generators changed everything. Water no longer had to power machines directly. It could produce electricity, and electricity could travel. For the first time, energy could be generated in one place and consumed in another. This is the moment when hydropower stopped being a local solution and became a system. Dams were built not only to capture energy, but to control it. Flow was regulated, seasons were smoothed out, rivers were transformed into assets, and with that transformation, hydropower moved firmly into the hands of states. Large dams were never just engineering projects, they were political statements. They reshaped landscapes, displaced communities, and reorganized entire regions. In the 1930s, during the New Deal in the United States, massive hydropower projects were built as symbols of national recovery and modernization. In the Soviet Union, electrification plants placed dams at the heart of industrial ambition. Across Scandinavia, rivers became the backbone of energy intensive industries. So hydropower was no longer just energy, it was control over water, over territory, over development. But even then, its limits were already visible. Rivers could only be dammed once. Geography could not be scaled. Environmental consequences accumulated slowly, often ignored at first, then impossible to reverse. Hydropower delivers stability, but it also fixed systems in place. It tied energy to long term infrastructure decisions that could not be easily undone. This is why hydropower belongs in this series. It didn't fail, it worked. And precisely because it worked, it locked the system into a specific way of thinking. Large projects, long timelines, heavy infrastructure, centralized control, decisions made once, then lived with 4 generations. Hydropower was one of the first ways energy became powered by the past, built to serve the future, but forever shaped by the moment it was created. So let's start with the most discussed and controversial hydropower project of the last decades. And it's a Belo Monte in the Amazon region of Brazil. On the paper, the numbers look impressive, an installed capacity of 11,000 megawatts, one of the largest hydroelectric projects in the world. But here is a hooking point. The actual average electricity generation is only around 4 to 5 terawatt hour per year, which means the plant operates at roughly 35 to 40% system efficiency. And that difference is not a technical accident, it is structural. The river flow is highly seasonal, and the reservoir is shallow and spread over a large tropical area. That creates another problem rarely shown in energy charts: methane. Studies have shown that tropical reservoirs like Belo Monte can emit significant methane during the first decades of operation. In some years, approaching the life cycle emissions of gas fired power plants per kilowatt hour. Add to this large scale ecosystem disruptions, loss of fisheries, international investigations. Belamonte does produce electricity, but it does so with a low effective return, high ecological cost, and a long list of consequences that never appears in the efficiency figures presented at the approval stage. So let's look at another one. Grande Dixens Dam in Switzerland. That is completely different example. The Grande Dixens Dam in Switzerland. Same technology, same physical principles, but at entirely different outcome. The installed capacity here is about 2000 megawatts, with an average annual generation of roughly 2 terawatt hour. At first glance, those numbers seem modest compared to Belomonte, but the system efficiency tells a different story. Thanks to alpine geography, cold climate, deep reservoirs, and full integration with pump storage operations, the effective system efficiency reaches 90-95%. So methane emissions are negligible, close to zero, because cold mountain reservoirs don't produce organic decay at scale. The electricity generated here feeds industrial regions, urban centers, and neighboring grids exactly when demand peaks. Ecological impacts exist, but it is geographically limited and tightly managed. This dam has been operating for decades without major environmental scandals, not because it has no footprint, but because the footprint was accounted for. This is hydropower functioning close to its maximum systemic potential. Not because the technology is different, but because the decision architecture is. Between these two extremes sits a case that represents how hydropower works in much of the world. The Aswan High Dam in Egypt. Its installed capacity is around 2,100 megawatts, with annual electricity production of approximately 10 to 12 terawatt hour, corresponding to a system efficiency of about 60-70%. This is not a failure. The dam provides electricity, irrigation, flood control, and industrial support for an entire country. But the trade offs are real. Located in a warm climate, the reservoir produces measurable methane emissions, though significantly lower than tropical rainforest dams. The more profound impact lies elsewhere. Sediment is no longer transported downstream. Soil fertility has changed, and ecosystems along the Nile have been permanently altered. There were no major corruption scandals on the scale of Belamonte, and no attempt to present the project as impact free. This dam works, it delivers value, and it quietly shifts environmental and social costs over decades. It is neither clean nor destructive by default. It is managed, compromised, operating at middle ground efficiency that reflects the system it was built into. If you listen carefully to how hydropower is usually discussed, you will notice a very specific pattern. The conversation almost always revolves around installed capacity, cheap electricity, and decarbonization targets. The numbers look clean, they fit neatly into reports. Hydropower feels like a solved problem. And that is exactly where the silence begins because there are things that rarely get discussed out loud. One of them is that hydropower is irreversible. You can dismantle solar panels, you can remove wind turbines, you can even shut down a coal plant and reclaim the land. But a dam is different. Once a river is blocked, it doesn't simply adapt, it becomes something else permanently. Sediment flows change, ecosystems reorganize, fisheries disappear, agriculture downstream is reshaped for decades. And then comfortable question, what if this was the wrong decision? Has no real answer because there is no reset button. Another thing that stays off stage is accumulated ecological debt. Hydropower is often presented as low carbon here and now, but many of its costs arrive slowly over 20, 30, 50 years. Reservoirs silt up, soil fertility declines, local climates shift. In warm regions, methane emissions persist long after construction ends. These timelines don't align well with how systems usually measure success, so they are quietly ignored. There is also a question that almost never gets asked directly: who actually receives the energy? In practice, large dams often serve industry, export markets, and energy intensive sectors first, while local communities carry most of the environmental and social burden. This imbalance rarely appears in performance metrics, but it defines how benefits and costs are distributed. And finally, there is the climate itself. Many hydropower systems were designed around relatively stable hydrology of the 20th century. Today, droughts, glacier loss, and extreme rainfall make that stability far less certain. Reliability, once assumed, is no longer guaranteed. Put all of this together, and the blind spot becomes clear. Hydropower is rarely treated as a long term management problem, it is framed as a clean transition story. But in reality, it is not a story about purity or progress. It is a story about how societies choose to live with the consequences quietly, permanently, and often far beyond the horizon of immediate decision. So, when we talk about energy, it's worth pausing for the moment, not to debate technologies, targets, or timelines, but to look at the pattern underneath all of it. Again and again, we measure what systems deliver today: megawatts, terawatt hours, efficiency ratios, and far less often we ask what they leave behind tomorrow. Because what we usually call progress is often a trade across time. Effects are moved forward, consequences are pushed outward, and the system keeps working just long enough for the cost to disappear from the view. We don't produce clean energy, we trade impacts today for waste tomorrow. And the real question has never been whether we do this. The real question is who ultimately pays for the consequences and how consciously the choice is made. This was Beyond the Business. Thank you for listening, and I'll see you in the next episode.